Hello everyone, welcome back. Today we'll learn some trigonometric identities under trigonometric functions, right? So I'm covering very important identities which are related to sum and difference of trigonometric functions of two angles, or I can say compound angles. So when I say compound angles, they are just addition or subtraction of two angles or more than two, right? So let's learn some formula and then we'll solve some problems based on those. So I request you to note down these formulas which are going to help you a lot in grade 11 and grade 12. Talk about cos function. Okay. So cos A plus B, cos A cos B minus sin A sin B. Alright. So here you have to remember that when I say cos function, so when it comes positive, then in the formula it becomes a negative, and this cos A cos B together. Okay, sin A sin B together. Same with cos A minus B, you have to simply flip the sign. Alright. Then sin A plus B, when I say sin sum function, so sin A cos B. So just understand sin and cos. Again cos and sin. Okay. So you can remember this, and when it is plus, then here it is plus only, and it is negative, then here it is negative. So this is how you can remember them. Alright. Then tan A plus B. So just tan A and then tan B. Okay, tan A plus tan B. And then 1 minus tan A tan B. So you have to just multiply them in the denominator and you have to flip the sign. Alright. You have to remember that tan is not defined for multiple of pi by 2 90-degree angles. So these are excluded. Alright. Tan A minus B, tan A minus tan B, and in the denominator you have to put the plus sign. Again, angles which are multiple of pi by 2 are not included. Cot, you have to flip this. So cot A cot B minus 1, okay, and then cot B plus cot A, or I can say cot A plus cot B. Why we have written this? Because here in the denominator it is cot B minus cot A. So to just remember the formula, we have written cot B first. And cot is not defined for the multiple of pi angles, right? Because sin pi is 0 or 2 pi is 0 and so on. So we have excluded those. These are some important results based on this formula. Okay. So you can just pause the video, note them down, and whenever required you can apply them. Alright. Now let's solve some questions based on that. Alright. So we'll start with some very easy question. Alright. Now here sin 23 cos 67. Alright. So sin and cos combination. So just remember that what formula we learned, sin A plus. Now here it is plus sign. So I'll write plus. Okay. So sin A plus B is equals to sin A cos B plus cos A sin B. Right. So I can straight away apply this formula. So applying this formula, what I can say, it is sin 23 plus 67 degree, correct? And 23 plus 67, I get 90, right? So sin 90 degree, which is 1, correct? Very easy question. Alright? Okay. Now we have to prove that this equals to 0. So we'll start with LHS. Now, first of all, we'll simply write the question. Now the LCM is cos A, cos B, cos C. So I multiply here with cos C and then sin A minus B over formula. So let me just remind you. Sin A minus B is equals to sin A cos B minus cos A sin B. Right? We know this. So I'll apply that formula and I'll write the numerator accordingly. So denominator remains as it is. Now here what do we get? Cos C into bracket. Here sin A cos B minus cos A sin B plus, open the bracket and then we can write the numerator again. So yeah, this requires a lot of space. Now here what I'll get, sin A cos B cos C. See, I have changed the order, okay? I can do that. Then sin B cos A cos C plus sin B cos A cos C minus sin C cos A cos B plus sin C cos A cos B minus sin A cos B cos C. So if you see this, we can cancel out this and I'll get 0. So this is the right hand side, correct? So we have proved that, hence proved. Right? Okay, perfect. Alright, now interesting question, tan 105 degree. So first of all, see, let's understand this formula, tan A plus B. Now we have to break this 105 in some known numbers, okay? So that I can apply this formula, tan A plus tan B over 1 minus tan A tan B. Okay, so I'll write this, tan 105 degree is equals to tan, now some known angles, so I can write this as 60 degree plus 45 degree because we know the value of tan 60 degree and tan 45 degree, right? And I can easily apply this. So now tan 60 degree plus tan 45 degree over 1 minus tan 60 into tan 45, right? So we apply this formula and you have to mention that which formula you are applying. Tan 60 degrees square root of 3 plus 1 upon 1 minus square root of 3. Now this is into 1, so let me just write, and now we have to rationalize this. So 1 plus square root of 3, 1 plus square root of 3. So what do we get? Let me just simplify the numerator also. So 1 plus 2 root 3 plus 3 upon, here it is 1 minus 3. So we'll get negative 2 in the denominator, right? And in the numerator 4 plus 2 root 3. So I'll write 2 plus root 3, right? And then I can cancel out and I can say minus of 2 plus root 3, which is my, now interesting question, okay? So let's understand how to solve this. So I'll take the LHS with the tan A plus B formula. So it is tan A tan plus tan B, right, upon 1 minus tan A tan B. So every time when you solve this question, you have to speak this formula so that you can easily remember it. Now when I divide this, okay, all of them by cos 15, then I can convert that into tan, correct? Now, so what I'll get, cos 15 upon cos 15 plus sin 15 upon cos 15 and then cos 15 upon cos 15 minus sin 15 upon cos 15, right? And now what do I get here? 1 plus tan 15 upon 1 minus I can write this as 1 into tan 15. Can I write this? Now tan 45 degree equals to 1. So what I can do, I can continue here with tan 45 degree, sorry, plus tan 15 degree upon 1 minus tan 45 into tan 15, right? So we have to apply this formula, okay, tan A plus B, we have converted tan 1 as tan 45. And now I can easily apply the formula, which is tan 45 degree plus 15 degree. And I get this as tan 60 degree, right, which is square root of 3, and that is same as RHS. Hence proved, right? I hope you understood this, right? Alright, perfect. Alright, now again we have tan form. So now you have the formula, okay, you know that. So let me just quickly write this. Tan A plus B, okay, equals to tan A plus or minus tan B over 1 minus plus, okay, tan A into tan B, correct? So now I am directly writing this formula, okay, but you have to write the LHS and then you can apply the formula. So tan pi by 4 plus, I have applied tan A plus B in the numerator and A minus B in the denominator. Now tan pi by 4 is nothing but 45 degrees. So I'll get 1. So 1 plus tan x upon 1 minus tan x. Okay. Whole upon 1 minus tan x upon 1 plus tan x. So I can write this as, let me just solve it here. I can write this as 1 plus tan x upon 1 minus tan x into 1 plus tan x upon 1 minus tan x. How? Because I have applied A upon B whole upon C upon D as A upon B into D upon C, right? Okay, and then what I'll get? 1 plus tan x whole square upon 1 minus tan x whole square, right? So that is nothing but the RHS. Very easy question, right? Okay, but do it carefully. Now, very interesting question, okay? See, we have to find the value of tan alpha plus beta. So, if I'll apply the formula first, okay? Tan alpha plus beta is equals to tan alpha plus tan beta over 1 minus tan alpha tan beta. Alright. Now, cot alpha is given as 1/2, where alpha belongs to pi to 3 pi by 2. Means which quadrant? Yes, it is third quadrant. In third quadrant, tan and cot both are positive. So I'll write this as cot alpha is equals to 1/2, which implies that tan alpha is equals to 2. Okay. Alright. Now sec beta is equals to minus pi over 3. And beta belongs to pi by 2 to pi, means second quadrant. Now in second quadrant, tan is negative. Alright, so I'll write this first. Sec beta is equals to minus pi by 2. So minus pi upon 3. Now tan beta, we know that that will be negative. So I'll just put the negative sign and then I'll write 1 minus, sec square beta minus 1, and then I'll get minus 25 over 9 minus 1. When I simplify, I'll get 16 upon 9 and then minus 4 upon 3. So we got the value of tan alpha and tan beta. So here 2 plus minus 4 over 3 upon 1 minus 2 times minus 4 over 3. And when I take this LCM and simplify this, what do we get? 6 minus 4 over 3 plus 8. So we'll get 2 upon 11, correct? Which is going to be my answer, final answer. The value of tan alpha plus beta. Alright. So you have to mention that why this is negative. Okay. Because this is in third quadrant, because beta belongs to, you have to say belongs to pi by 2 to pi. Alright. And here alpha belongs to pi to 3 pi by 2. You have to mention this quadrant. Alright. Perfect. Now here this is very interesting question. Okay. So we are given that cos alpha minus beta plus cos beta minus gamma plus cos gamma minus alpha equals to minus 3 by 2. And we have to prove cos alpha plus beta plus gamma is 0 and sin alpha plus beta plus gamma is 0. Alright, now just pay attention here. See, what I'll do, I'll just take this 2 on the left hand side. So I'll multiply each of them by 2. And then I'll write this as cos alpha cos beta. Now this is minus sign here, so we have to write the plus sign and then sin alpha sin beta, right? I have applied the cos formula. Alright, plus same way. So cos beta cos gamma is equals to negative 3. Alright. Now see what will happen when I multiply them by 2 times. And then I'll bring this negative 3 on the left hand side. So let me just write this. 2, this is cos alpha cos beta. Plus 2 sin alpha. Okay. Now see, cos alpha cos beta. Same way cos beta cos gamma and cos. Same way here we have sin form thing. So now what I'll do, this 3 I'll break into 1 1 1. Okay. 1 plus, see, 3 I am writing as 1 plus 1 plus 1. Now we know that sin square theta plus cos square theta equals 1. So now what I'll do, I'll just replace this 1 as cos. First of all, we'll just write this, okay? Plus 2. I'll bring all the cos term together. 2 cos beta cos gamma plus 2 cos gamma cos alpha. Now same way for sin. Sin alpha sin beta plus 2 sin alpha beta sin gamma plus 2 sin gamma sin alpha. And now I am writing this 1 plus 1 plus 1 as sin square gamma plus cos square gamma plus sin square beta plus cos square beta plus sin square gamma plus sin square gamma plus cos square gamma equals 0. Now we have to apply the identity of sin a x plus y plus z whole square, right? To get this as the terms. So I have the cos square alpha, cos square beta, cos square gamma plus this. So I can directly write this as cos alpha plus cos beta plus cos gamma whole square plus sin alpha plus sin beta plus sin gamma whole square. and this is equals to 0. Now when here it is addition, then both are equals to 0, and then what I can say, cos alpha plus cos beta plus cos gamma is 0, and sine. So therefore cos alpha plus cos beta plus cos gamma equals 0, and here and, okay, not or, sin alpha plus sin beta plus sin gamma equals 0. So hence we proved this. Alright. So very interesting question, and I would request you to solve this carefully. Okay. So that you can understand what we have done so far. Alright. Now very interesting question once again. So we are given tan alpha value, tan beta value and tan gamma value, and we have to prove alpha plus beta equals to gamma. Hint is in our answer only. Okay, so I have to prove alpha plus beta equals to gamma. So what I'll do, I'll start with this tan alpha plus beta value. Okay, all right. Now I'll simply put the formula and then substitute the value. So first of all, the formula is what? Tan alpha plus tan beta 1 minus tan alpha tan beta. Correct? And now I'll substitute their values. So here 1 upon square root of x into x square plus x plus 1 plus 1 upon this is square root of x and square root of x square plus x plus 1 minus 1 upon x into x square plus x plus 1 into square root of x square plus x plus 1. Alright. Now when we take the LCM and simplify this, so what do we get? Here the LCM is just square root of x. So I'll get 1 plus square root of x square over square root of x into square root of x square plus x plus 1. To simplify, I am writing this way. Okay. Now here 1 minus square root of x upon square root of x into square root of x square plus x plus 1. Again I am getting this. See, to make you understand, I am writing this way. Okay. Now in the numerator, what do we get? 1 plus x. Okay. Then here root x will get cancelled out. This is x square plus x plus 1. So I am writing this as x square plus x plus 1 whole upon this square root of x, okay, into square root of x square plus x plus 1 from this. And here when I simplify, I'll get x square plus x plus 1 minus 1. 1 plus x square root of x square plus x plus 1, and denominator I can take x into x common from this. See, I have x square plus x, so I can take x common, so I'll get x plus 1 and then this square root of x. Alright, so I'm going to cancel out this too. So this is, now I can simplify as, I'm writing it here. So I can write this as square root of x square plus x plus 1 over square root of x to the power. So this is, so I can write this as square root of x to the power minus 3 plus x to the power minus 2 plus x to the power minus 1, which is nothing but tan gamma value. So now tan alpha plus beta equals to tan gamma. So this implies that alpha plus beta equals to gamma. Hence we proved it. Alright. So do it very carefully because it is really complicated. Alright. Perfect. Now one more interesting question. So here we have to prove that sin square A equals to this given value. So we'll start with the RHS value. And I'll rearrange them as cos square B plus cos square A minus B minus 2 cos A minus B into cos A cos B. Alright. Now I'll write this as it is cos square B. Then I can take cos A minus B common. So cos A minus B common. Now what is left here as cos A minus B minus 2 cos A cos B. Now I apply the formula of cos A minus B for this. Okay, so what I'll get? Cos square B plus cos A minus B into, now I can write this as cos A cos B plus sin A sin B minus 2 cos A cos B. Correct? And then I can write this as cos square B plus cos A minus B, and then I'll get this as cos sin A sin B minus cos A cos B. Correct? So this is nothing but cos square B plus, now here this is cos A minus B. Now I have to take the minus sign common. So I'll take minus sign common, and then I can write this as cos A cos B minus sin A sin B. Right? And then I can apply the formula. So I will get cos square B. This is minus now cos A minus B, and when I apply the formula I'll get cos A plus B. Now we learned the important result, right? So if you have written that, I can apply the important result for this. So what do I get? Cos square B, and then minus, I can write this as cos square A minus sin square B. And then we can simplify this as cos square B minus minus plus sin square B. I can write together minus cos square A. So this is what 1 minus cos square A, and this gives me a sin square A. So this is LHS. Hence we proved it, right? So very important question, alright. I hope you understood this. If not, then please check this again. You can share with your friends, so then they can also get the benefit out of it. Alright. If you like this, please write in the comment box. If you have any doubt, please let me know. And thank you for watching.